A couple final examples of being able to work with the second order differentials. This time they're going to have the repeated roots just like the last one did, except we're going to have to take it a step further. So almost the exact same differential as we had in the previous problem, except we just changed the coefficients just slightly. Unfortunately, that's going to make the problem a little bit more difficult, but not terribly more. So let's start by finding the complementary solution. Complementary solution yc m squared minus 2m plus 1 is equal to 0, factorable into m minus 1 squared equals 0. And so we have that repeated roots case to where both of the roots are going to be equal to 1. So we have case 2. And from the case 2, we know that yc is going to be equal to c1e to the 1x plus c2x e to the 1x. Okay, we're going to hold on to that. So now we need to find the particular solution. And we're going to guess. We have a linear term and we have an exponential term. And so the good news is we already know it because it's the exact same one in the previous problem. So we're going to guess ax plus b plus c e to the x. Similar to the previous problem though, there looks to be some repetition. So unfortunately, c e to the x looks exactly like c1 e to the x, so we can't use that. So what we did in the last problem was we tried a different one, and we said, let's try cx e to the x. And that worked nicely. In this problem, it's not going to work, because if you notice, cx e to the x actually looks like c2x e to the x. So that doesn't work. So what do? We just go up one more power. We're going to get cx squared e to the x, and that's going to be the one that we need to make this work. Okay, so understand how the repeated roots work. Compare the particular and the complementary solutions and look for duplication. All right. We still need to find successive derivatives. There's going to be a couple product rules going on here. Derivative of ax is a, derivative of cx squared 2cx e to the x plus cx squared e to the x. That's just by our product rule. Second derivative, we're going to have to use two product rules. Derivative of 2cx, 2c e to the x. Derivative of e to the x, e to the x. So that's going to be plus 2cx e to the x. All right, so that's our first derivative. And then for our second term's derivative, derivative of cx squared 2cx e to the x. Derivative of e to the x is e to the x, so we have cx squared e to the x. All right, and notice that we can combine like terms. So our second derivative of the particular solution, we can now write that as 2c e to the x plus 4cx e to the x plus cx squared e to the x. All right, so before you go on, maybe pause the video just to make sure you're okay with the algebra, make sure you're okay with being able to compare the particular solution and the complementary solution. All right, just because in general this is where students make mistakes, is maybe finding the y prime p and the y double prime p. All right, so hopefully you've gone through, you've justified everything. We're going to shove everything back into the original differential, which was y double prime minus 2y prime plus y is equal to e to the x plus x, or x e to the x, doesn't matter. And so we already know what our second derivative is. So that's 2c e to the x plus 4cx e to the x plus cx squared e to the x. We're going to subtract from that 2 of the first derivative, which was a plus 2c x e to the x plus cx squared e to the x. Right? And then finally, we just have y, the original guess, which was ax plus b plus cx squared e to the x. So ax squared plus b plus cx squared e to the x. And remember, all of that was equal to x plus e to the x. All right, so now what we need to do is we need to combine like terms. And at this point, we better hope that some stuff cancels out. I'm going to focus on anything that has x e to the x first. So we have 4cx e to the x. And then we also have negative 4cx e to the x. So we have a negative 2 times 2. So those cancel out. That's good news, by the way. Next, I want to focus on anything that contains x squared e to the x. So I have one of those x squared e to the x's. I have negative 2, so that's 1, negative 2 of those. And then I have another one of those from the cx x squared e to the x. 1 minus 2 plus 1, they all go away. All right, so that's really good news. So realistically, what are we left with? Well, we are left with 2c e to the x. We're left with this term. We're left with minus 2a. And we're left with ax squared plus b. Actually, that should just be an ax plus b. I don't know where I got the square from. You all were probably yelling at me about 5 minutes ago when I copied it. So this is an ax plus b. And remember, that's equal to x plus 0 plus e to the x. And now at this point, it's really easy for us to derive our system and to get to the solution. All right, so we have a is equal to 1, so we're matching up coefficients. So that's easy. We have that negative 2a plus b is equal to 0. And then finally we have that 2c e to the x, so 2c is going to be equal to 1. All right. At this point, trivial. A is 1, c is a half, and then over here, if a is 1, that means that b is going to be 2. Just by substituting back in and then adding 2 to both sides. So our particular solution, yp, is going to be equal to 1x plus 2 plus a half of e to the x. And so our y of x, which is yc plus yp, is going to be equal to c1 e to the x plus c2x e to the x plus x plus 2 plus 1/2 e to the x. All right. Actually, I think it should be 1/2 x squared e to the x, right? Because I think we guessed right, cx squared e to the x. All right, so I made a copy error there, so excuse me. So that should be x squared e to the x. And then down here, this should be an x squared e to the x. All right, so I apologize. All right, this is our solution. All right, if you want to, go ahead and find a couple derivatives, plug it back in. I wouldn't suggest it because it makes it pretty tough. All right, I'll do the other problem in a different video just because I think it's going to take a little bit longer and I don't want the videos to run too long. But hopefully this makes sense, especially with that repeated roots business. Again, check the complementary, check the particular solutions for duplication.